Hello everyone, welcome to my channel. Today we're gonna learn how to connect this ESP development kit to Arduino. These development boards bring out all the pins that is linked to this chip, so it's easy to connect them to anything. And the easiest way to program them is in Arduino, and today we're gonna get right to it. Now let's head over to the Arduino website and download the software. So here we are at the Arduino website. If you don't have the website, you can find a link down in the description. The first thing we've got to do is we click here on products, then we go to Arduino IDE, and then you select your appropriate operating system and click download. And then we wait and wait. After the download is complete, you can simply install the app and then you are ready to go to the next step. Now you guys are probably thinking, this is an ESP32. Why are we downloading Arduino? Well, lucky for us, Arduino supports third-party boards. There's simply an added process that you need to follow so that you can use this board on Arduino. Let's start with that now. Now we head over to ExpressIF to download the third-party board links. You guys can find the link down in the description, then just follow that and it will take you right to the exact part of the documentations giving us the links we need to add into Arduino so that we can use our ESP32. Let's have a look. So this is the stable release. We can copy that or you can use the development link over here. If you are situated in China, then you should use these links as the above links are very slow inside China. So what you can do is simply click this button and it will copy the link. Then we head to Arduino and I'll show you where to add the link. Now that we have our link copied, we open our Arduino app. Then we go to File, Preferences, and at the bottom you'll see there is Additional Boards Manager URLs. Then we click on this button on the right hand side. We paste our link that we copied from ExpressIF website and we click OK and OK again. Okay, next we're gonna head over to Tools, then go to Board Manager. Then you'll notice on top here there's a search bar. Then you type ESP32 and we get two results. The first one is Arduino ESP, that's a board developed by Arduino. The next one is ESP32 by ExpressIF, so we're looking for that one. I already have it installed, but if you don't have it installed, instead of update here, you'll see install. Then you simply click install. It's going to look the same like if I click update. Basically what it's going to do is going to download all the new packages and install it. Then we'll carry on from there after it's done. Okay, so after we've added our board to our board manager, we simply take our ESP32, connect it to a USB cable, then we connect our other side to our computer, and then we go from there. Now that we have our board connected, to make sure it's really connected, we go to the bottom right hand corner here. Then you'll see the ESP developer module on COM4. Then we know we are connected. Then everything is right. Now it's time to head over to ExpressIF to check the pins of the ESP32. The next thing we've got to do is we've got to check the input and output ports of the ESP32. So we'll head over to ExpressIF to check their documentation. You can find a link down in the description for that. So here, if we have a look, we have the GPIO. and that means general purpose input output. Then we have a number next to each one. Then also here for the analog functions, you'll notice there's a ADC2 channel and there's a ADC1. Normally ADC2 and the Wi-Fi conflict a little bit with each other, so we always tend to go for ADC1. But for this we'll just use a digital output to turn on a little LED. So we're gonna go with pin 25. Now the next thing is to check the board. Where is pin 25 and what is on the actual ESP? So here is a zoomed in picture of our ESP32. This is the connector where it connects to your USB cable. It's a similar connector as the old Android phones. This chip is a CH341, which is a USB to serial chip, which is used for programming the ESP32. This tiny guy over here is a voltage regulator. This is the chip made by ExpressIF. Now you'll notice each pin is numbered. So like we said earlier, we're going to use pin 25, which is located over there. Then another thing to note is here is your 3 volt pin. Here is actually 3.3 volt. This is your 5 volt pin, and all the pins that have ground on them, like for example this one says GND, this is a ground pin, and here we have another ground pin. So that's useful to use because in any circuit you need to know where are your ground pins, where are your 3 volt 3 pins, and where are your 5 volt. Generally you don't want to really power something massive of the 3 volt 3 pins because they can only put out a little bit of current. So it's best to use an external power supply but connected to the same circuit. Now to test our ESP, what we'll need is a cable like this and a small LED. With the LED, the shorter leg is negative and the longer leg is positive. So we'll connect the negative leg to the ground, which reads GND, and the positive leg to our pin 25. So now I've got the purple wire connected to pin 25 and the white wire connected to the ground. Then I've respectively connected it to the LED. Then now the next step is to get to programming. Now that we have everything connected, the next thing is to head over to Arduino IDE to do our code. Now the first thing we need to do is we need to check that we have selected the correct board. This is especially important if you have multiple boards that you're using. In our case, we selected ESP32 developer module and it's on COM port 4, and that is correct. The next thing is we need to go here to void setup. This is basically the code that runs before your board goes into a loop. So any setup or any settings you want to apply, you need to do it over here. The only one we're interested in now is telling the pin 25 that it's an output pin. So to do that, we'll say pin mode 25 output. So now pin 25 is assigned as an output pin, so we can put out a signal to it. Now we have this section called void loop. Whatever code goes inside here loops over and over and over again. So your main program runs inside the void loop. So for us to test our board, we're gonna turn on the LED and then turn it off again. In order to do that, we need to output a signal to pin 25. In this case, we're going to use a digital signal. So for that, we'll use digitalWrite. Then tell it is for pin 25. And then in order to switch it on, we simply say hi. Then the next thing is to add a small pause. And in order to do that, we write delay. Now this is in milliseconds, so if we want to pause for half a second, we'll write 500 milliseconds. Then if we want to flash the LED, we need to switch it off again. So we'll say again digital, write, pin 25, and then we'll write low, which will switch off the LED. Then we add another delay of 500 milliseconds, which is half a second. So what this will do, it will switch on the LED, then pause for 500 seconds, then switch off the LED, and then pause for another half a second. And then this will loop over and over and over again. Now that we have completed our code, the next step is to upload our code to our board. In order to do that, we'll go here to Sketch, then click Upload. Now, some boards you have to press the boot button in order to upload it, and some you don't need to because it can upload automatically. But depending on your board, it's kind of important to take note of that, otherwise it will just stick on connecting. This particular board doesn't need the boot button, so it just uploads it automatically. And just like that, our code is on our board. Wow, and look at that, our LED is flashing. Now, if we want to make our LED flash faster or slower, we can simply change the delay times. For example, I'll change the delay time down to 100. Wow, now we can see that the LED is flashing faster. That's because I changed the delay from 500 milliseconds to 100 milliseconds. Now that's it for this video. Next time we'll go deeper into digital output and digital input. Thank you for watching. See you next time.